Okay, so now let's look at question 6. An oil drop of mass m carrying a charge is in the region between two horizontal plates. When the potential difference between the upper and lower plate is V, the drop is stationary. Okay, so this is an important concept. I underline it first, explain later. The potential difference is then increased to 2V. Okay, sorry, the question is on another page. So what is the initial upward acceleration? Okay, so that is the question. Remember this. What is the initial upward acceleration? That means A equals to what? Okay, and you have to give it in terms of the symbols. Okay, so now the question is okay, when the potential difference is V, the drop is stationary. Okay, when the drop is stationary, what does this imply? That means resultant force is 0, right? Okay, that's we learned that from your dynamics. Okay, so I'm gonna draw out the problem and then we'll analyze it from there. Okay, so okay, now we have two parallel plates. Okay, we do not know their charge, the charge of the plate. Okay, but we know that the difference is V. Okay, the difference is V, or rather delta V. Let me just put that. So now I have a charge here. Okay, it has mass m. I'm going to put a comma here. Okay, m comma q. Okay, it's not g. M comma q. So what this means is the characteristics of this charge is it has mass m and it has charge q. Okay, so now we need to have this condition. Okay, that when the potential difference is V, okay, when potential is V, resultant force is 0. Okay, and okay, now when they change the potential difference to 2V, okay, there must be acceleration. Okay, if there's acceleration, what does this mean? That means when, okay, I write a different column. Okay, don't be confused. When it's 2V, potential difference is 2V, okay, your resultant force is non-zero. Okay, but your resultant force is ma. Okay, this is Newton's second law. Okay, so now let's draw a free body diagram. For this charge, there's weight always points downward, right? Okay, so we have a downward force, let me call F1. Okay, F1 is actually mg. Okay, F1 is mg. Okay, to balance this mg, we obviously must have an upward force. Okay, F2. Okay, F2 must be, the only other force that could be from this problem is EQ, right? Okay, so therefore, if let's say this is a positive charge. Okay, positive charge, positive. Okay, therefore, to have an upward force, that means to be attracted to the upward plate must be negative. But that is not important. Okay, we just need to know that there are two forces, and when it's V, resultant force equals to 0, that means EQ minus mg equals 0. This is the resultant force, right? That means EQ equals to mg. Okay, so this is this concept. So now what happens if it is 2V? Okay, when 2V, resultant force is non-zero. Is non-zero, right? Okay, let me rewrite F2. F2 is equals to EQ, which is also equals to V over D. Okay, VDQ. Okay, V over DQ. So if let's say I increase this to 2V, right, then F2 will be increased. Okay, right, if I increase this distance, the potential difference to 2V, F2 will increase. So now what is my resultant force? My resultant force now, okay, is equals to ma, is always equal to ma. So that is my first equation, right? My second equation will be 2VQ, okay, 2VQ minus mg. Okay, So then, let me combine the two equations. Okay, so 1 equals to 2, resultant force is the same, so MA equals to 2VQ minus MG. Want to solve for A, so I divide throughout by M. A must be equals to 2VQ over M minus G. Okay? Right? Okay, and that is answer C. 2VQ over M of MG. C is your answer. Okay?